Okay guys, Batman here. Gonna follow up on Harry the Crop Circle Pirate. Now, as you might remember, in the first of the Math with the Fat Man presentations, we were talking about conic sections. And one of the fun ones is the hyperbola. And the definition of a hyperbola is the locus of all points, the distance of which, you know, let's call this A and let's call this B. It's all points where the A minus B equals a constant. So it makes a shape kind of like this, and it's always a double shape too, because you've got this is the same A and this is the same B. So that's a hyperbola. A minus B equals some constant K. That's from the first Math with the Fat Man. Now, in the first Harry the Crop Circle Pirate, let's get in closer so we can see. Yeah, you can kind of see that. Now, in the first Harry the Crop Circle Pirate, we told the story about Harry, who has a long string with lawnmowers that are 60 inches apart from each other, and he turns those lawnmowers loose and they cut a swath in the grass, and that those lawnmowers collide with the wall at certain places, and then Harry leaves and burns down all the grass. First he buries his treasure right where he's standing, and then he leaves and burns out all the grass. And so you find the wall, and you have to solve where's the treasure buried, knowing that Harry uses lawnmowers spaced 60 inches apart from each other, and that he buries the treasure under where he's standing. So that's Harry. Harry the CC number 1. Now, in Harry 2, which didn't come out very well so far because the lighting was bad on it, we explored a really cool thing that came to me of how to solve it, which is that since we know that all we know is these collision points on the wall, and we know about the 60 inches. So there are only a certain number of places where Harry could be standing in order to have caused a collision here. But this only worked, so I mapped out all the possible places that he could stand and cause a collision there, and then I did the same thing for this one, and then for this one, and it turned out that all those lines intersected at one point, and that's your winning point. The problem with that is that assumes that Harry's line is divisible by 60 and that he's holding it exactly 60 inches from one of these lawnmowers. So I wasn't really satisfied with that solution. But check it out. Here's where it all comes together. Harry's standing here. Let me move this in closer because this is exciting. Okay. We got Harry standing here. He's got his rope out here. Here's a lawnmower. Here's another lawnmower. And this distance, let's call it lambda. That's my version of lambda. And this lawnmower is going to crash, and then this other lawnmower is going to crash here. This distance D and this distance E are related by the following formula. You ready for this? Of course, D minus E equals lambda. So that means that given 2 points where those lawnmowers have crashed into the wall, the only place that Harry could be standing is some place that's D minus E equals lambda, which is the same as A minus B equals K, which is a hyperbola. So the only places that he could be standing are along this hyperbola here, or along this one here, right? that's if you've got 2 points on the wall. But as soon as you've got a third point on the wall, get the same thing, another hyperbola, and when you solve it, it's going to come up with an intersection spot, which is where the treasure's buried. Or maybe it's buried down here. No, because the marks are on that side of the wall. So here's the wall, here are the collision marks, and every pair of collision marks defines a hyperbola of possibilities of where Harry could have been standing to make that mark, because the distance between the rope that holds this lawnmower and the rope that holds this lawnmower, the total length of rope that holds this one and the total length of the rope that holds that one, the difference between them is 60 inches, which is lambda. So you can always solve the math for those two. I haven't quite gotten so far as to understand the math for it, or to review the math for it, but I've been working on it. So that completely solves problem 1, which is how do you find the treasure? And hopefully next week we'll find an elegant way to find the treasure even if you don't know what the distance between the lawnmowers is. Okay, this is Fat Man, best friend of Harry the crop circle pirate, saying stay fat and be careful where you bury your treasure, because some math dude is going to find it. It's all right.